Hi, I'm Angela Rasmussen from the University of Utah Department of Electrical and Computer Engineering, and I'm going to go over some examples today. So to recap, the steps for solving an RC or an RL circuit is that when you want to draw the initial circuit. So you have to determine, and I usually recommend draw the circuit and leave out the switch itself and the element. And so redraw that circuit first and then determine before the switch moves, what does that switch look like? Is it closed or what position is it in? And then you would draw the switch position. And then for a capacitor, you're going to leave it in, you're going to assume that it's been sitting for a long time, so it's going to be open. An inductor, you would assume it's been sitting for a long time and shorted. And then from there, you're going to solve it to find voltage for a capacitor and current for an inductor. And then there is one little step in between these, and that is after you go from that initial, you have to redraw the circuit at 0 plus, and then you're going to put in so I'm going to put a little, side note in here for 1A, and on 1A, you are going to redraw circuit again. And again, leave out the switch and the capacitor. And then in this case, you're going to do it at 0 plus time. So right after the switch has moved, and you're going to determine switch position. And for the element, for a capacitor element, you're going to replace with a voltage source. And for an inductor, you're going to replace with a current source. And then from this one, you're going to solve circuit for the initial value, and this time will be your initial value. Solve the circuit for variable that you want. And this is going to be your initial time. After that, you're going to draw the final circuit. And then again, the capacitor sitting for a long time, or you're going to draw the circuit, leave out the switch, leave out the element, replace the switch when it's in its final position. So if it's closed in its final, or whichever position it's in. So draw the position of the switch and then draw the element that's been sitting there for a long time. Again, capacitor's open, inductor's short. And then solve that circuit for, again, in this case, the circuit's going to be the final one, so you can solve it for whatever variable element you're looking for, or for the voltage for capacitors, or current for inductor, or any other element that you want. The only other trick for this is this other additional step where you need to, if it is not the voltage or the current and it's some variable in the circuit, you're going to have to take this one little extra step. After that, you're going to draw the circuit again, going to leave out the switch, leave out the element, and in this case, you're going to try and find tau. And so you want to remove all of the independent sources to find the resistance, and you're going to put A and B across wherever the element location is. So you're going to leave both of them open, the inductor and the capacitor, but put A to B at that location. And then you're going to put the switch in the final position and solve for RTH, and then find tau from RTH. And then from there, you're going to write the final general form solution. And remember, the general form solution is final plus the initial minus final, e to the minus t over tau. And that will be if it's a different variable or anything else. All right, so this is a summary recap of how to solve for RC and RL circuits.